All right, so in this lesson, we are also going to be dividing, just like we did in the last lesson, 4-5. This is just a continuation. That's why it's 4-5b, but we're going to talk about another way that we can do division that is a little bit shorter than long division, and it's called synthetic division. And it is just a shortcut. The only problem is that synthetic division will only work if you're dividing by a binomial of degree 1. So it is a little bit limited, and it's not good in every situation, but in these situations it is much, much faster. So here's how it works. We're going to take our divisor, set it equal to 0, and solve. So we get x is 1. And 1 is what we're going to put in our box, a little half box, to separate it from all of the coefficients of the thing we're dividing into. So we're going to list all of these coefficients out to the side. So 2, -3, 4, and -3. 2, -3, 4, and -3. We're leaving off all the letters, which is helpful for those who struggle a little bit with the algebra of the letters. And we are only dealing with the numbers now. So we're going to leave a space in here because we're going to write in this space. And here's how synthetic division works. We're going to bring the first number straight down every time. Then we're going to take this number and we are going to multiply times the number in the box. So 2 times 1, we write it in this next little space, and then we're going to add these together. So -3 plus 2 is -1. Then we're going to multiply again. Multiply the bottom row times the box. So -1 times 1 is -1. And then we add 4 plus -1, or 4 minus 1 is 3. Multiply times the box, I get 3. And add -3 plus 3 is 0. These numbers represent the coefficients of my answer. And my answer is always going to be 1 degree less than what I started with here. So this was x to the third. That means my answer here is x squared. So this first number is the coefficient of my x squared term minus 1x plus 3, or 2x squared minus x plus 3. Okay, well, I want to show you something from yesterday's assignment. Look at this problem. We're dividing by x minus 1, is the same problem that we did with long division, right here. 2x squared minus x plus 3. 2x squared minus x plus 3. But this is much shorter and a whole lot easier. Now, we already knew yesterday, we talked about that this thing didn't factor again. We tried. So, although if it would, we would write all of the factors, but since it does not, then the product of factors would be our original factor and the answer that we got. Because if I multiply those together, I would get what I started with. All right, so that is synthetic division. Much easier. So let's try another one here. Remember, the first thing we're going to do is take this, set it equal to 0, and solve. So that's the number that goes in our little offset box, and then we list the coefficients: 2, 3, -8, -12. Leave us a little space and bring down the first number. Then you multiply. 2 times 2 is -4. Then we add -1. -1 times -2 is 2. And we add, and we get -6. -6 times -2 is 12. And we add, and we get 0. So this is 1 degree less. So we have 2x squared minus x minus 6. So again, if you take yesterday's notes out, or the long division notes out, it's the same answer that we got here. And then we want to see if it will factor again, so we can write the product of factors. So 2x squared minus x minus 6. Factor that out. We have 2x times x. This was going to be 3 and 2. We want a negative 4 plus 3. So negative, positive. And so the product of factors would be the original factor times what we got when we factored out our answer. So I multiply all these back together, I get the original problem. And sometimes we might know how to do division, either long division or synthetic division. But when the problem looks a little different, then we think we don't know what we're doing. But if you'll look, this is just another way for them to ask us to do the same thing that we have done in the last couple of problems. Here it says that they want us to divide f of x by h of x. So this equation divided by this equation. The same thing we've been doing. So if I want to do that, then using synthetic division, I set that equal to 0 and I get 3. And so I'm going to put 3 in my little box and the coefficients out to the side. But everywhere there's something missing, I need to put in a 0. So I've got 1 x to the 5th, but I don't have any x to the 4th. I've got a negative 3 x to the 3rd, an 8x squared, no x's, and minus 24. Leave us a little space in there so that we can write in it. And we're going to bring down the first number. So we bring it straight down. We multiply times the box. 1 times 3 is 3. And we add. We get 3. Then we multiply again. 3 times 3 is 9. Negative 3 plus 9 would be 6. Multiply times the box. 6 times 3 is 18. So then we're going to add 18 plus 8 is 26. And then we multiply 26 times 3 is 78. And 0 plus 78 is 78. So 78 times 3 is 234. So negative 24 plus 234 is 210. So this is not quite as clean and nice as the ones that we've been doing, because every one of the other problems that we did, when we got to the end, we had a 0. We got to the end, we had a 0. So the other day when I was talking about dividing, I talked about a remainder. Well, that's what this is. This is my remainder. If I were going to write this out as a solution to this problem, what do I get when I divide? Well, what I get is 1 degree less. So this is going to be 1x to the 4th plus 3x to the 3rd plus 6x squared plus 26x plus 78 with a remainder of 210. So it's 210 out of what I divided by, x minus 3. The remainder goes over the divisor. Now, in some instances, this is what they want. They want to know what was the answer. What do you get? But the answer itself also holds another little piece of information that's sometimes helpful when you're trying to talk about solutions or graphs of these functions. So back over here, whenever we got a 0 at the end, that meant that this was a 0, or a place where the graph of the original function would have crossed the x-axis at 1. And this one, this graph crosses the x-axis at negative 2. That's because the point 1, 0 is on this graph. In this one, the point -2, 0 is on the graph of this function. Well, if that's true, then in this situation, the point 3, 210 is on the graph of the original problem here. Now, is that helpful in finding a 0 or an x-intercept? No. But does it give me some information about my graph? Yes, the graph goes through the point 3, 210. And it also is telling me that if I were to put 3 into this problem for x, I would get 210. So let's go ahead and do that. If I were to put 3 in here, 3 to the 5th minus 3 times 3 to the 3rd plus 8 times 3 squared minus 24. Let's see what I get. All right, so here it is. Typed all that in. 3 to the 5th minus 3 times 3 raised to the 3rd plus 8 times 3 squared minus 24. I get 210. So this remainder is what I would get if I plugged 3 into the original problem. So that's another piece of information, and this is called the remainder factor theorem. If the remainder is 0, like on the other side of this paper, then the divisor is a factor of the original polynomial. But if it's not 0, the remainder is still a solution at that particular point. So f of 3 is 10. Whatever number I have in this box, this is my output value. So when I put in 3, I get 210.